As I mentioned in our last video, there are a total of 6 different kinds of quadric surfaces. What I'm going to do is break them into 2 different groups. We'll talk about the unambiguous cases first. I refer to these as the unambiguous cases because based off of the traces, there is only one possibility of what this thing can be. So first and foremost, the first unambiguous case that we're going to talk about is the following. Now, taking a look at this, we have x squared over a squared plus y squared over b squared plus z squared over c squared is equal to 1. What we're going to do is take a look at each of the 3 different kinds of traces that it has and identify what kind of conic section each of those is. Now, as I said in that video, what you're technically doing is setting a variable equal to a constant and then identifying what kind of conic section you're left with. Now, what I find to be a little bit easier is if you're going to set something equal to a constant, set it equal to the most straightforward constant that there is, 0, or whatever would cause this thing to be 0. If I cover up the z variable, you're now taking a look at the xy trace. What I see here is an x squared plus y squared. They're both squared, they're both on the same side of the equation. What you have here is an ellipse. If I do the same thing for the y variable, I'm now looking at the xz trace. Xz trace, as you can see here, is also an ellipse, also a sum of 2 squares. Yz trace, if I cover up the x variable and take a look at the y and z variables, once again, both squared, added together, this is an ellipse. So regardless of the direction that you perceive this thing, what you get is a cross-section that is an ellipse. The 3-dimensional figure that you have is referred to as an ellipsoid. The best comparison that I can give for an ellipsoid would be a football. And for the international students, not a soccer ball, an American football. Really, American football should probably be called hand egg or hand ellipsoid because you use your hands and it's an ellipsoid. So there you go. The second unambiguous case. Now, as a reminder, I'm giving all of these with an orientation about the z-axis. So next one, we're going to allow the z variable to be on one side, and the other 2 variables are squared on the other side. Once again, I'd like to look at the traces. Z trace and the yz trace. Alright, so taking a look at these traces, not necessarily setting it equal to 0, but if I do cover up the z variable, I see once again that we have a sum of 2 squares. For those 2 variables, that cross-section would be an ellipse. For the xz trace, if I go ahead and cover up the y variable, we have a first power on one side, a square on the other side. That is an upward opening parabola. And finally, for the yz trace, if I go ahead and cover up that x variable, we're now looking at a first power variable as well as something squared. Once again, we have an upward opening parabola. So, what do you call it when you have an ellipse and 2 parabolas as far as the traces are concerned? Well, essentially what you have here is, from one perspective, it looks like a parabola. From another perspective, it looks like a parabola. And cross-sections would be ellipses or circles. I don't think I drew that particularly well. It's supposed to look more like a satellite dish. This is referred to as an elliptic paraboloid. However, if you do a Google image search for elliptic paraboloid, I'm sure that you'll come up with something much better than what I am capable of drawing. The other unambiguous case that we have looks similar to the previous case, but with one major change. Major change is going to be the fact that these squares are now going to be subtracted. So once again, if we take a look at the traces, xy trace, xz trace, and the yz trace, Alright, xy trace, we go ahead and cover up that z variable I see that we have a difference of two squares. Difference of squares is indicative of a hyperboloid, or excuse me, hyperbola. The xz trace, if we cover up that y variable, we have a parabola, and that parabola opens in the upward direction. Parabola. And I'm also going to indicate that it opens in the upward direction. For the yz trace, if we go ahead and cover up that x variable, this time we wind up with a parabola again, but because of the negative in front of the y squared, that's going to be a parabola that opens in the downward direction. So from one direction, it looks like the vertex of the parabola should be a minimum because it opens upward, and from the other direction, it looks like it should be opening in the downward direction. So in one direction, it looks like it's opening upward, and in the side to side, looks like it should be opening downward. There is no way that I am going to be able to draw this properly on a two-dimensional surface, but what I will let you know is that this is referred to as a hyperbolic paraboloid. Now, quick naming mechanism that gets used throughout this. If you have at least two traces that are the same kind of thing, that becomes your noun in 3 dimensions. Ellipse becomes ellipsoid, parabola becomes paraboloid. To distinguish between the two different types of paraboloids, take whatever the other trace is and turn that into an adjective. Ellipse becomes elliptic, and a hyperbola becomes hyperbolic. Now, quick comment about the hyperbolic paraboloid, because these have fantastic real-world applications. From one direction, it looks like it's a local maximum, and from the other, it looks like a local minimum. This kind of point that you have in here is referred to as a saddle point. For those who have never saddled up a horse before, you need a thing that allows your legs to dangle over either side, so looks like a maximum in that direction, but from front to back, you don't want to move from where you are. So it's referred to as a saddle point. Saddle points stack exceptionally well. Something else that stacks especially well would be Pringles. Pringles are the #1 application of hyperbolic paraboloids. Anytime you eat Pringles, you are eating a stack of hyperbolic paraboloids. Oh my gosh, learning is so much fun. I need some sour cream and onion. I'll be back.